Okay, so here we are back trying to figure out what consistent units are. In Appendix A, which is in the back of your book, open right now. There's a real good, though there's a lot of appendices, but this particular, the first couple appendices tell us what symbols are used for what quantities, and then what units in U.S. customary units, and then or standard, what I keep calling them, or metric units. So that's really nice. There is a Q in here. It's right here. It's called flow rate. In the US, we use our flow rate gallons per minute or standard cubic feet per minute. That's what SCFM means. I see there's a little glare there. Or the metric system uses liters per minute or cubic meters per minute, which would be real nice for us since we've got liters and meters in the same problem and we need to figure out how they relate. And there's more. There's more along that same unit for horsepower, all kinds of stuff. In Appendix B, there's the metric prefixes, which are really nice. You know what kilo is, what micro is, nano, pico, giga, tera. That's good. Some conversion factors to convert pounds to newtons and so on. Again, we're going to have some of that in our discussion that was earlier. And pressure, temperature, power, vacuum. And I'm looking for volume. There it is. Volume right there. That's what a liter is. 1 liter equals 0.001 meters cubed. That's going to be something that's going to help us a bunch. So just to write it down in our problem, 1 liter, 0.001 meters cubed. This is, if you're in a math class, this is what they call dimensional analysis. But basically, I want to convert the units from this problem to something that I can actually use, especially in the answer where they're looking for the size of the pipe, which I first have to figure out is area of the pipe. And area is going to have lengths or distances, and it's not going to have cubic. If it's not going to have cubic, I need to think, well, gee, do I want to keep things in units of liters, or do I want to keep them in meters? Liters a cubed quantity. I do not want to keep that. I want to keep something in meters, centimeters, inches, whatever, some unit of length. So I want to convert my liters to meters. And somebody said, hey, by definition, somebody created this unit called a liter that says it happens to be equal to 0.001 cubic meters. They're the same thing. It's like saying the number 1 equals the number 1, or the number 1 equals A and A equals 1. It's like saying the same thing. So I am going to take my liters, in this case 75 liters per minute, and I'm going to multiply it by, if these two things are the same quantity, they mean the exact same thing by definition, that's not equals. If I was to write something like this, that would be the number 1. It's the same thing divided by itself. And I can multiply anything by the number 1 and not change its value. So that's what I'm doing right now. I am going to take 75 liters per minute and I'm going to multiply it by 0.001 meters cubed per liter, and that's going to give me 0.075 meters cubed per minute. That's a beautiful thing, and that's still equal to Q. It started out equal to Q, and it's still equal to Q. That's a lot easier number to work with, especially with this. The equation in the book said that flow rate equals velocity times the area. Well, now we have a flow rate in units of meters cubed per minute, a velocity in meters per second. I do have to make the time things more compatible. Seconds is not the same as minutes. That's pretty easy to do. They're just going to cancel out in the end anyway, because area doesn't have a time. Doesn't matter which one I convert it to. It's probably easier for me to multiply numbers by 6 meters per second than it is for me to multiply factors by 0.075 meters cubed per minute. So that's what I'm going to do. I'm going to take my velocity and I'm going to say that 6 meters per second, or is the same as saying 6 meters over seconds, which is how I really wanted to write it. There has to be some conversion between seconds and minutes. It's actually in the back of the book somewhere under time, but you may know this, that there is 60 seconds in 1 minute. They're the same thing. And so we can do the same thing we did here, getting the liters and meters to cancel. We'll do it with seconds and minutes. So I'm going to take 6 meters per second, multiply it by 60 seconds, 1 minute, and that's going to give me 360 meters per minute is also our velocity. It's the same thing as 6 meters per second. So now I've got Q in units I can work with. I've got velocity in units I can work with, and it's getting long again. I need to stop.